guys, today we're going to be looking at geometric series. I know we usually go about finding the patterns and then dropping the formula. At this point, we're not going to try to drive the formula for geometric series. The reason being is that it's a little bit more complicated in order for us to see the patterns. So I'm just going to give you the formula that I think is the best formula for us to use, which is S of n is equal to, which represents for sum of the first nth term, is equal to a sub 1, first term, minus a sub n. It could be interpreted as the nth term or the very last term, a lot of times, times r over 1 minus r. So that's the formula that we want to use. If you look in the book, there's another formula for you. They're going to tell you, well, if the problem gives you this and this, use that. Guys, if you want to go ahead and memorize it, you can. I'm not a big fan of memorizing anything. I'm a big fan of understanding something. So I like this one because once I know my a sub 1 right here, a sub n right here, even if I don't know my a sub n, I know there's another formula secretly, right? From previous lessons, I know that I can find it by a sub n is equal to a sub 1, that's a, times r to the n minus 1. That's minus. Alright, so I can use that to find a sub n. So I'm not that worried about the other formula. So let's look at where we can use this formula. It's just a very simple example. So I'm going to give you a sequence. So if I give you a sequence 2, 4, 8, 16, and 32. First of all, this is a finite sequence. Why? Because I made it that way. No particular reason. I just wanted to give you a really simple example, and that's the only reason why. Now what I want to do, I want to dissect this. I'm going to use this right here, and what I'm looking for is a sum. Series means sum, so I'm going for this right here. And if you wanted to, you're more than welcome to just plug this in the calculator, crank it out, and see what you get, right? But here, once again, we're going to try to use a formula and make a use out of it, so let's look at it. N. So once you look at it, I want to plug in for n, right? So we're thinking, do we have n? No. But look again. It's a finite sequence. That means it has a certain number of terms. How many terms do we have? We have noted that we have 5 terms. If there's 5 terms, that means n is equal to 5. Okay, so our n is equal to 5, so I'm going to plug that in. So our s of 5 is equal to, fortunately we know our a sub 1, which is 2, minus, what's our a sub n or a sub 5? You already know that, right? Which is 32. Times what's our r? Our r, let's look at it. Let's look at it. Every time I am multiplying it by 2. Multiplying it by 2. So r is equal to 2. Gonna go ahead and plug that in. Now, once again, I will minus r. So all I'm going to do, I'm gonna solve this thing out. So we now have s of 5 is equal to 2 minus 64, right? All I did is I just multiply those two, 32 times 2. Oh, I forgot to put r in. R was 2. I apologize. So 1 minus 2, so you get negative 1. Now put in your calculator, do it in your head, whatever you want to do. So what's 2 minus 64? It should be negative 62 over negative 1. Put this in your calculator, do it in your head. Negative over negative gives you just positive 62. So what this means is that right here, s of 5, that means sum of first 5 terms. Right? So we have 2, 4, 8, 16, 32. There we are. 62. This is exactly how you would use this formula. You'll use this formula over and over again in your homework, and you're going to find yourself thinking, well, this is nothing like what we did in this small little example. But you know what? You are doing the same thing. So please let me know if you have any questions. This was a very short lesson. I hope this helped. Once again, if you have any questions, email me and let me know what all I can do, okay?